Here we go. Welcome back to the highly requested build where our mechanic has been restoring this 1978 Datsun Z for 2.5 years.
The restoration has finally reached the most complex stage, which is the engine. Today, we will walk you through the detailed restoration process of key engine components. The very first part we are tackling is the unfor cylinder head. It is one of the most popular versions in the Z series, featuring a higher compression ratio and larger valves for massive power potential. However, this specific head was originally designed for electronic fuel injection, so it has notches in the intake ports for the injectors. Since we are converting back to a traditional carburetor, these notches disrupt airflow and fuel mixture, so they must be completely filled. You might notice that the first two intake notches have already been seamlessly filled in. Let's take a closer look at exactly how he achieves such a flawless and invisible repair. To patch these large gaps, he inserts a 10mm aluminum rod directly into the notch and welds it into place. This method is highly efficient, avoiding the thermal stress and potential warping caused by heavy structural welding. Moreover, the 10mm rod is carefully measured to fit perfectly snug inside the groove. Right now, he is prepping the surfaces by grinding and thoroughly cleaning the contact points before the actual weld. Once perfectly cleaned, he taps the aluminum rod into position, saws off the excess, and grinds both ends down. He intentionally leaves a slight overhang rather than grinding it flush, which greatly helps with the upcoming welding process. For the weld itself, he opts for laser welding, which generates so little heat that you can safely touch the metal barehanded. This eliminates the need for preheating and prevents heat distortion, and the weld is completely done into distinct stages. Step 1 uses only the laser without any filler wire to cleanly fuse the base metals together without leaving impurities. After this initial pure metal fusion, the surface may look a bit rough, but the structural bond is incredibly strong. For step 2, he uses a 1.2mm aluminum filler wire to lay down cosmetic beads and fill in any remaining low spots. With the patch fully welded, he grinds off the excess material for a smooth finish, which leads us to an obvious question. Why downgrade from a modern fuel injection system back to an older carburetor when modern tech is supposedly better? For old-school gearheads, it is all about raw throttle feel rather than technology, because an ECU treats your pedal input merely as a suggestion. A carburetor lacks electronic precision, but it offers a direct mechanical connection where fuel delivery flawlessly matches your foot. While average drivers would not notice the difference, this 50-year-old fuel injection system is far from modern or efficient anyway. Back then, ECUs lacked self-learning capabilities and had very few sensors, making replacement parts almost impossible to find today. In the tuning world, swapping these inline-six engines to triple carburetors sacrifices fuel economy for aggressive and instantaneous throttle response. With the rest of the intake notches successfully patched up, our custom cylinder head upgrade is finally complete. Next up is the valve cover, which is structurally fine but suffers from an ugly spark plug wire routing stretching right across the top. It features 3 threaded mounting bosses explicitly designed to hold cheap-looking brackets for those bulky ignition wires. This ruins the beautiful vintage look of the valve cover, so we need to rear out the wires and shave off those obtrusive bosses entirely. With a solid goal set in mind, he cleans the entire valve cover by media blasting it with a gentle glass bead abrasive. After thoroughly blasting it, he uses the laser welder to completely fill those 3 mounting bosses from the inside out. Because these cast aluminum pieces are hollow directly behind the bosses, grinding them off from the outside would just leave massive holes. Therefore, he has to carefully backfill the cavities with fresh weld before grinding the exterior protrusions completely flat. After leveling the bosses, he drills out the internal threads and creates a chamfered edge, which serves a structural purpose. The chamfer creates a wider welding surface to ensure optimal penetration, followed by a final heavy grind to beautifully blend the repair. With the bosses entirely deleted, he gives it a final pass in the blast cabinet to unify the surface texture for an absolutely stunning result. However, he correctly notes that the factory breather port is a major eyesore, but relocating it is not as simple as just moving a hole. You have to maintain its critical ventilation function, as the inside features a specific baffle plate that is open on the right and sealed on the left. The internal routing currently channels blow by gases through the gap on the right, so moving the port requires entirely altering this flow path. To reverse the gas flow efficiently, he must extend the baffle plate to seal off the right side and drill fresh vents into the left side. This effectively flips the ventilation pathway entirely, and with a concrete execution plan in place, he starts modifying the cover. He begins by grinding off the old port's protrusion and internal threads, then plugs the hole using an aluminum patch just like before. After welding the patch securely into place and grinding it perfectly flush, the original breather port completely disappears from existence. He then tackles the tricky curved section of the baffle extension, utilizing a smart technique of tack welding it securely into place before fully burning it in. With the heavy welding complete, he meticulously shapes the piece, grinds down the harsh edges, and chamfers the corners for a highly professional finish. After a final quick blast to clean it up, he uses the newly extended baffle plate to precisely trace the exact location for the new breather port. Lacking a drill bit quite large enough for the bulky new port, he slowly bores it out with a rotary tool before installing the fresh fitting. He precisely welds in a pre-blasted and chamfered L-shaped elbow, meticulously grinding off any internal threading that protrudes inside. After seamlessly welding the elbow to the modified valve cover and cleaning up the exterior seams, the breather relocation is finally finished. You might notice the elbow is slightly angled, which is a highly intentional design choice to route the hose neatly past the protruding lip below. Now he just needs to carefully drill out the fresh ventilation holes on the left side of the baffle plate, ensuring they are properly chamfered for optimal flow. A final overall media blasting unifies the surface texture, successfully concluding all the complex structural modifications to this beautiful vintage valve cover. It will eventually receive a highly specialized surface treatment, which has been outsourced to a professional detailing and coating shop. If we manage to get footage of their process, we will definitely share an update, but for now, thank you so much for tuning into Max's Restoration Garage.